Dartboard Paradox and understanding the probability density function for continuous distributions. What is the dartboard paradox? Let's say we throw a dart onto a dartboard and let's say it cannot hit outside the dartboard. So that means the probability of hitting somewhere on the dartboard is 1. But the probability of hitting any specific point on the dartboard is 0. How can all the zeros add up to 1? So this is the dartboard paradox. This is not so much a paradox as it is in terms of understanding what a probability density function is. So let's recapitulate some properties of a PDF or a probability density function for a continuous variable. The probability of a continuous random variable taking a specific value is 0. But note that the PDF is not the probability. So for any specific value, the PDF can be non-zero, even though the probability is 0. What are we talking about here? Like, what is the difference between PDF and probability? So in fact, for a continuous random variable, the PDF can take values even greater than 1, while the probability can't. So if you look at this plot here of a normal distribution with mean 0 and variance 0.1, you see that clearly the value of the PDF is going above 1. So it's going to like above 4 and so on, right? So let's understand this better. What is this difference between the PDF and the probability? So the probability can only be defined on a small range. So I can say probability of x lying between a small range a and b, a less than or equal to x less than or b, less than or equal to b is integral from a to b fx of x dx, which is integrating over the PDF or the density function, right? So you can derive the probability from the PDF. So the PDF is non-zero, but if you take a point, the probability is not defined for like, a point does not have any area or it does not have any length. So the probability is 0. So to understand this better, we can take the analogy of milk. Let's say I tell you the density of milk and then I ask you, what is the weight of milk here? Can you answer? You can't, because in order to come up with the weight, you need to know the size of the container. So if you recall, mass is density into volume. So you can come up with the weight from the mass if you know the volume along with the density. And this is where the whole notion of density comes from. Even when we define a probability density function, we cannot talk about a probability without defining the range or the area over which we are computing it. And once we define that area, we can integrate over that area, the PDF over that area to get the probability. So let's recapitulate some of the properties of a continuous probability density function. So fx of x, the PDF, is always greater than or equal to 0. But note that it can also be greater than 1, unlike probability itself, which cannot be greater than 1, right? Integral minus infinity to infinity, fx of x dx is 1. When I integrate over the entire range of the values that x can take, the PDF will sum to 1. And the probability can be derived from the PDF as probability of a less than or equal to x less than or equal to b is integral of a to b fx of x dx. So once I define a range, I can talk about the probability. And to sum it up, in the case of the dartboard paradox, we cannot talk about point probabilities. We can only talk about the dart hitting a small area on the dartboard. And if you look at that probability, that will be non-zero. And when you integrate over the entire area of the dartboard, the probability will be 1. So that's a continuous probability density function and the dartboard paradox. Thank you.